A warm welcome to our great set of speakers who will take us through this session, giving us great insights on deep learning on AWS. It's a pleasure to have you in this webinar. This event is hosted by deeplearning.ai and AWS Cloud Educate student ambassadors who've done a great job in organizing. From this session, we expect to garner knowledge on how to get started with AWS on starting our journey on AWS Cloud Services. We also expect to learn best practices of developing and deploying deep learning models on the AWS Cloud. We'll also get to discover how companies are disrupting and transforming various industries by building fast, scalable, and flexible machine learning models on the cloud. Couple of things to remember during the webinar. Our speakers will answer your questions at the end of the webinar. Please feel free to post them on our Slido platform using the link provided. Also, keep posting the proceedings of the events on Twitter, LinkedIn, and all other social media platforms that you wish to. Use the hashtags, hashtag AWS Educate and hashtag DeepLearningAI. I repeat, hashtag AWS Educate and hashtag DeepLearningAI. Before we start, let's have a greetings video from Dr. Andrew Nju, the founder of deeplearning.ai.
Hello, deep learners. I'm Andrew Ng, founder of deeplearning.ai, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the deeplearning.ai offices and meet some of the teams so that you can see where it all happens.
Oh, hi, Andrew.
Do you want to tell our friends at Pine AI what you do at deeplearning.ai?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on The Batch?
How much is going on in this field? There is never a dull moment. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so I'll let you get back to it.
Thanks. See you later.
Let's go meet Kian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey Kian, so do you want to tell the people at Pine AI what you're working on?
Yes, sure. I'm leading a project called Workera, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
You know, the AI field is new. Organizations and jobs are still misunderstood. So I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
Yep, and that's really important work. Well, it's nice chatting. And now let's go chat to Hotel, who is on their product team. Do you want to say hi to our friends at Pine AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in deeplearning.ai, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, also.
Thanks, Andrew.
So, as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project. or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pine AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot, both from the talks and from each other. And once again, welcome to the deeplearning.ai community.
We'll begin with our first speaker, Mr. Jianjun Zhu, who will take us through the first session, getting started with AWS Cloud Services. Therefore, without further ado, welcome, Mr. Jianjun.
Hi, my name is Jianjun Xu. I'm a senior solutions architect with AWS Education. So AWS Education is a little different from the program you guys are working with. That's AWS Educate. That's focused on working with students. AWS Education, we work with researchers and institutions, universities and institutions, helping them doing their research. So let me first just introduce, give you some, for people who are not really familiar with cloud computing or AWS, a brief, give you a good basic idea what cloud computing is and what kind of services we're talking about here. So cloud computing is, it's considered cloud computing this very similar to the way you use electricity. You go into a room, you turn on the light, and then you start using the electricity. When you leave the room, you turn it off. So it's on demand delivery of, instead of power, it's actually on demand delivery of IT resources via the internet. And you pay as you go. That will help you to reduce your cost of instead of running a large data center and then not 100% utilized, you still have to keep it on when you're not using it. Cloud computing is when you're using it, you pay for it. When you're not using it, you don't pay for it. And instant scalability is a really important piece, especially for people are doing a very large amount of computing, high performance computing, parallel computing, or machine learning. Sometimes when you're doing image processing, you will need multiple GPUs and very large machines for a very short period of time. In order to do that, normally you will be buying, getting budget in place and get financial approval and buying those machines. But now with the cloud computing and AWS, you don't have to do that. You just go provision an instance. For example, our P3 16 extra large. It's multiple GPUs, very large machines, hundreds of the virtual cores, and you can use. You can run your image processing for an hour or a day, and then you can shut it down. And you don't have to worry about the cost of those large machines. Instant scalability is really important in research, especially. What's the benefit of using a cloud service like AWS? Agility, cost saving, elasticity, and with all those benefits, let's say if you're a researcher, you're doing large-scale genomics research, right? So instead of provisioning those large arrays of computers to do data analytics or build your model, you instantly get access to large amount of compute. That's the agility we're talking about. And then the amount of money you pay is a fraction of what you have to spend on your data center. With all this benefits, you can start innovate really fast. If you have a model, which is really important in higher education or research, not all the ideas you come up with are good ideas, right? But you want to try out. You want to try those ideas to see if it works. With those agility and elasticity, and you can experiment with your idea really fast. That's what we mean by innovate faster, right? And also, if you need to touch an audience around the globe, then you can go global in minutes. I'll show you a little later how you can do that with our global network. So those are the core services are the storage, compute, network, security. Those are the foundations. And then on top of that, we build special purpose-built databases, and then the frameworks we put in place so you can do AI, ML. So before I introduce individual services, let me just touch a little bit on the global network we're talking about. So AWS has 24 regions. Those are basically geographic locations around the world. A region is consists of multiple availability zones. You can think about availability zone as clusters of data centers, not just one data center. We have more than, usually have 2, 3, more than that in some regions, or AZs. Those are the cluster of data centers that are connected with very high speed network cables. So they are also designed for disaster recovery. So, and for example, a local event, a flood event, for example, won't affect more than one data center. So we also built our own system called Nitro system. Those are the chips that with specific cards on our hardware to improve the performance of the network and storage. And then let's talk about storage a little bit. So there are 3 different kinds of storage: block storage and file storage and object storage. So object storage is probably something that you guys are going to use a lot when you're doing machine learning. It's called S3. It's different from the regular file system or the block storage you're talking about, you're familiar with. So let's just leave it at that level. And once you put something in AWS in an object storage, it will become really highly available. So if you look at those numbers here, once you put a file in AWS S3, the object storage, we actually make more than 3 copies in different data centers. So you will never lose that data. Those are the different types of storage. We also have different ways for you to move your data to a cheaper location. Let's say if you have a large amount of data, you want to do some data processing, you can put it in S3. Once you move it over, once you finish processing those data, we'll have services to move them automatically to a different class of storage. So you don't have to pay too much for that. And then if you have a large amount of data you want to move to the cloud, we actually have those devices. You can put terabytes and terabytes of data. If you have petabytes of data, you can actually use something called a snowmobile that can move 100 petabytes at a time into the cloud. Networking, so I'm not going to dive really deep into that, but anything that you can do in your local data center in terms of the networking, creating subnets, create different virtual private cloud VPCs and routing, and also you can use direct connect and all this to connect to your on-prem database data centers. Those are the typical things every data center needs to be done, can be done in the cloud. And also the one very good big benefit of doing that in the cloud is you can write code to do those. Infrastructure as code. You can spin up a data center in the cloud really quickly with code. Security, of course, is really important. Anything before you do any work in the cloud, you need to think about security. So we have a shared security model. All the services we provide, I mentioned compute, storage, and database and networking. Those are our AWS responsibility. We take care of the security of those. But when you are putting your workloads or building a model or putting data in the cloud, and you need to worry about the things on the top. How do you configure your network, firewalls, how to protect your data, how to encrypt your data. Things like those are your responsibility, but we provide a lot of security features for you to build those features, security really, really easily. So those are just a list of the services that you can use to secure your data and network. So we provide native encryptions to help you to encrypt your data when your data is at rest or when it's in transit. You can protect those with those services we provide. Those are the basic services we provide. And then on top of that, so let me, the data analytics, I can talk about that for days, but because we have a very short time, I'm going to just start with this this picture here, and touch on some of the services we provide. So you can do the entire data analytics pipeline in the cloud. So on the left-hand side, this is where your data source is. Normally, you have a ERP or a learning management system, student information system, those things, or you can have individual users, their mobile phones, their IoT devices. Those are all your data sources. In AWS, we provide a large array of those services for you to host your service. For example, we have streaming platforms, so you can produce videos and images. And then we have IoT devices that you can connect to the data stream to send data in real time. And then we have our purpose-built databases that you can build your application on top. All those data sources will send data into the cloud. So they can build your pipeline. Glue is an ETL service. We use to ingest data, and then once the data is in the cloud, you can use something like AWS Batch to process those. And then if you have real-time data, you can use Kinesis Stream and to process Lambda, use Lambda function to process those data to put in a data lake. A data lake is a new concept. It's compared with the data warehouse, it's a lot more flexible, and you can put a lot, and it can process a large amount of data. It's perfect for big data and also for real-time streaming data. Once you put it in there, you can build a data catalog on top, and those are the services that you can use to deal with those data. And then once the data is ready, then that's usually, it will take, this part of the process will probably take you 70% of your time to get your data in a good shape. Once you do that, you can feed it into your machine learning or perform data analytics. All those components of the data pipeline can be built with or without server in the cloud. So this is a limited, this is just a collection of our customers. They are currently doing machine learning on AWS. To support our machine learning services on AWS, we built a lot of different services and instances, large machines for you to do training and also for you to do inferencing. So those are the instance types. But one thing I want to mention is this new inferential chip. This is the chip we built just for you to perform inference at a much lower price. So the stages of machine learning is like you start with data, you build a model, right? And then you feed your training data into that model, and then you tune the parameters and you build the model itself. Once you build the model, you have to make your model available for other people to send their data and just get the predictions. Those are the inference we're talking about. Normally, you use a large machine to do the machine learning training. You spend a lot of time doing the training, but once you are done with the model, the inference doesn't take a lot of compute, but they sometimes require a large array of the capabilities to process large metrics, right? So to use a large machine with a lot of GPUs to do that inferencing is a waste. So we built this inferential chips just to solve that problem. It performs certain tasks, the inferencing tasks, really fast, and it's much cheaper than having a GPU machine up in there running all the time. So that's something that keep in mind when you're building our models. This is the machine learning stack. So there's a lot in this, but in general, there are 3 layers. So if you are, for you guys, you're thinking about becoming a machine learning practitioner, so you'll probably need to build your own models. So this is what you use. The lower layer is called the frameworks and the infrastructures. We support TensorFlow, MXNet, and PyTorch. We invested a lot in MXNet recently. We built a lot of models a lot of the SageMaker algorithms are built on this with this framework. And then there are higher level frameworks and the Keras and the gluons, and also once you build the model, you need to run on certain machine. You used to have to provision the machine, install all the Python packages or the libraries you need. And then you need to choose how many GPUs, or you can only work with what you have, right? But for us, we build all those on the right-hand side, the lower level, that are AMIs, and we containerize those AMIs. And then that's why I mentioned a little earlier that for getting familiar with container is really helpful, is that whatever you want to do, and I want to run MXNet model on a machine with 6 GPUs or 8 GPUs. You can just call up one line of code in SageMaker, says, I need this. And then we'll spin up those containers and put your code in this container and then connect with your data and run it in that container. So you don't have to provision a machine. So make it really, really, really powerful. So for the SageMaker Studio, this is the Jupyter Notebook environment that you will be building all your. On top of that, we actually build really a higher level AI services. So you can do vision, speech, text, chatbots, all without writing code. So those are the high level AI services. If you go to AWS, I believe you all have AWS Educate account now. Then you can go play with those services, upload the image and see what information you can extract from that image, or build your own chatbot, use Lex. Lex is the chatbot behind Alexa. All those services put together, and then you'll be able to do your machine learning a lot easier. I'm just run through really quickly the building models in SageMaker. SageMaker is our machine learning, the go-to solution. The first thing you want to try after you log into AWS, I would just strongly suggest that you look up SageMaker and SageMaker Studio. So for supervised learning, we have all those. These on the right-hand side are deep learning. You can use a couple line of code to start your object detection. I might have time to show a screen of SageMaker with the object detection and the image classification. Those are the unsupervised learning. You can use PCA to do dimensionality reduction. And then once you have your data in a better shape, you can use k-means, for example, to do the clustering. Those are the existing services. Then you can just use APIs to call and in your Jupyter Notebook to run. You don't even have to build a model. We already built the model for you. You just need to provide your data. So SageMaker Studio is a new service we released recently. It's built on top of the SageMaker, the Jupyter Notebook. It provides an environment for you to be able to track your experiment and also provide debugging. To go through your, in the process of building a model, you'll be able to do that. So I am gonna end here and also spend a couple of minutes to show you what the SageMaker environment look like. So here's my email. If you have any questions, you can send me emails. And I strongly suggest you, if you want to do a deep dive into the deep learning, the D2L.ai is a very, very good free resource for you. They got a lot of sample code you can just run directly in SageMaker. Once you log into the console and then you start up your Jupyter Notebook, this is the button I want you to click first. The SageMaker examples, all those a list of examples that you can use. And one more example. So this object detection, you use the P3 instance. You start your SageMaker session, and then you show us where your data is. In this case, it's in the S3 bucket. And then this is the part that really is the key of this model, right? You're basically telling me that you need to run, you need to build an object detection model in SageMaker, and then we'll get you this container image. Once you have that image, This part is just looking at the data, processes the data. This is all you need to do to build your model, your object detection model, is that I'm going to use this container I specified. It's called object detection. And then I am going to run this in this P3 instance that has 1 GPUs. And then these are the hyperparameters, or some of the parameters I'm going to pass you. And then once you get that, and then you feed the data, you set the hyperparameters here. And then you call this OD model.fit. And then this is going to train that model. This is all the training that you have been doing. And then you put that model as the inference, as the endpoint. This is all you need to do. And then here we go. So we pass the images to the model, to the inference point. The inference will come back with the name of the object and also boundary boxes of those object models. This is the really easy way to start your deep learning. And then those are just different examples of those. So yeah, with that, I think I don't want to run over time. So thank you so much for having me here today. And let me know if you need any other follow-up.
Thank you so much, Mr. Jianjun Su, for that enlightening session that you've taken us through. It was a comprehensive introduction to AWS for data analytics and machine learning. We thank you so much for your time and for sharing your experience and your knowledge with us today. Mr. Ewere will be taking us through building fast, scalable, and flexible machine learning models on AWS Cloud. Thank you, Mr. Ewere, for taking time to join us today. Welcome.
Thank you very much. It's a pleasure to meet everyone here. So today I will be talking about something a little bit different from what was mentioned, but I'm going to also delve into it. So most of the part of my talk will focus more on something not so different, but something that it's more like what you need to do first of all before you start talking about building of machine learning models. My name is Ewere. I'm the first AWS community hero in Africa. I've been a software engineer since 2003. Used to write Visual Basic code then. And then I'm the co-founder of DevOps Nigeria, where we have over 2,000 members currently as we speak. I'm also the first speaker at the first AWS community meetup in Nigeria. I was the only speaker representing Nigeria at AWS Loft at Joburg. I'm a blogger on YouTube. I also blog on my own Medium account. I'm also a speaker too, and I'm a cloud and DevOps engineer, and I am a father. So without further ado, let's go straight into data engineering and talk about how AWS helps us with end-to-end data engineering and making data available and preparing data for machine learning building and deployment. So first of all, we'll focus on what is data engineering. So data engineering is an aspect of data science that focuses on practical application of data collection and analysis. For all the work that data scientists do to answer questions using large data sets of information, there have to be mechanisms for collecting and validating that information. In order for that to work ultimately have any value, there also have to be mechanisms for applying it to real-world operations in some way. So the major tasks involved in data engineering include collection of data, cleaning up of the data, and then loading that data into a particular environment or location for analytics or performing analytics on that particular data. It involves various simple and complex data pipelines that perform what we call an ETL continually. So ETL means extraction, transformation, and loading. So basically, data engineering focuses more on extraction of data, transforming of the data, what we call cleaning of the data. Basically means we're trying to prepare the data for training on the machine learning models or for AI activities and for training of models, both for machine learning and for deep learning. So there are certain things we need to know and understand before we go a little bit deeper into this session. So I'm trying to highlight them one after the other. The first term we have here is called extraction. So this means collection of data from different sources. So different sources could mean an application in a server, could mean from a mobile device, could mean from a website, could mean from any other kind of wearable device. So it means collecting that data from that particular phone and from that particular device. The next is about transformation. So what does transformation mean? Transformation talks about cleaning of data, which means preparing that data for the next stage and ensuring that that data, it meets certain standards and conforms to certain principles that you need that data for. Loading means writing that data to the location to be used for further analysis. So when you extract the data, you clean up the data, you make it in a particular form that is more usable, and you load it. So that process is what we call an ETL process: extract, transformation, and loading. The other term that are so important is what we call a data swarm. So before you perform your ETL process on your data, you might want to dump your data into a particular location, and within that location, you don't intend to do anything. You just dump the data for the purpose of trying to scan through and understand what is actually in that data at that point in time. So what you do is you dump all the data from the different sources and the different locations where you have data stored. So it could actually be streaming data, which is data that comes in real time, or it could be data that is actually dumped already there that you have to extract. The next we have here is what we call a data lake. So a data lake is a location for storing raw or semi-clean data. So you can actually call data that you have, say, partially transformed, that is in a location, a data lake, because the importance of a data lake is where you start fine-tuning concepts of what you intend to use that data for. Data lake is where you go to actually see what has been done so far in terms of cleaning up that data. So data could be in form of images, where you collect a lot of images, but you want to train a particular deep learning model to understand certain kind of faces. Now, some images might not meet up to your requirements. So you might need to be able to clean up a lot of the images you get and extract and filter out the particular images that you are going to use to train your model, because good data means good model, means good prediction, and means intelligent and more powerful artificial intelligence. The next we have here is data mart. So a data mart is a business layer structured to give different business functions insights. So basically, a data mart is more of a subsection of a data warehouse, which is the next term. So some business functions will want to get some kind of 180-degree statistics of, say, a staff of a company. So from, say, all the salaries the person have been paid, all the promotions the persons have gotten, all the taxes the person have paid. You just want to get a 360 degrees of that particular individual. So that could mean getting data from HR, getting data from accounts, getting data from different departments, and sectioning it to just what account needs to see and understand about that person. It could also be customer data. You just want to understand the spend of a particular customer at a particular point in time, and you tailor in that mart into a specific part of the person's life, which could be maybe spend on data in a particular month. So that's what we call a data mart. So it gives a business layer, a specific business layer. It could be account, it could be human resource, it could be operations, details of a particular insight or data. The data warehouse is a combination of all data sources to form a summarized 360-degree view of all company and business data. So basically, the warehouse is where the C-level executives make their decisions and their final says. It is where we combine all the data of the business, all the data from different departments to form a holistic 360-degree view of what is going on in the business in terms of accounts, human resource, operations. And also for the part of applications, when you have a data warehouse, it serves as your source of truth for anything that has to do with your applications and your services and what is going on at any particular point in time. So it's the most powerful and it's the heart of your system and where everything happens. And then the last is more of a concept which we call data archiving and cold storage. So it's storage of data that is not accessed regularly but can be referenced on a later date. So data archiving is very important because you have organizations who have loads and loads of data. You might not necessarily need to keep that data in your data lake on your data mart so that you don't clump it up with data that you don't necessarily need. So you can actually section that data and move it over into an archiving or a cold storage that you don't often go to, but you go there once in a while to just pick out some data to use for analysis. So within AWS, both of those terms I just explained about data engineering actually have specific services that do them, and these are the services in AWS that are tailored towards each of those concepts and those terms in data engineering. So you have AWS Glue. AWS Glue is more of an ETL service for ETL operation. So AWS Glue is so powerful that it comes in with Spark, it comes in with Python, it comes in with a powerful ETL process that is fully serverless. So you write your jobs and give it to Glue. What Glue does is it takes the jobs, cleans up the data, and it also comes with Spark SQL. So you can actually pick data from your location or from your storage and clean up that data and rewrite it to where you want it to be. So AWS Glue is very powerful and does that very fast and quite efficient in doing that. The next we have is Amazon EMR. So Amazon EMR is more or less, I'll call it the more open source version of AWS Glue. So what EMR does is gives you the full access to the full blown Hadoop set of tools. So from Spark to every single service actually that the Hadoop stack has to offer, you have access to that. So when you set up an EMR cluster, you are able to set up many of those services like Scoop, okay, for extraction of data that comes with Hadoop. So those people who are Hadoop experts, they usually enjoy using EMR because it gives them that flexibility and that opportunity to explore and work with data extensively. Amazon S3 is a simple storage service which has already been talked about, and it's simply for storage of objects. So in some cases, I used to use S3 as a data lake because it can store almost infinite data. You can store as much as terabytes to petabytes of data in S3, and you can never exhaust the limit. So you can build strategies around making S3 a data lake for storing your data and partitioning the data accordingly. The next we have is the Amazon Data Pipeline. So Amazon Data Pipeline is an end-to-end ETL application. So Amazon Data Pipeline more or less replicates Amazon AWS Glue, but the difference is before Glue came up with the DAG flows, Amazon Data Pipeline had what we call a DAG flow. So a DAG flow is a sequential process that helps you to plan the extraction, transformation, and the loading of data, or it could be an extraction, a transformation, and transformation before the load of data. But what sticks data pipeline out is that it gives you a more visual form of the full ETL end-to-end process. It gives you a more sequential process. Just the way step functions are used for sequential processes. So Amazon Data Pipeline gives you a step-to-step sequential process for where you're extracting data from and where you are writing the data into eventually and what you want to do with that data. The next we have is lake formation. So based on customer demand, Amazon released lake formation, and lake formation is the building block of your data lake. So it has the features that comes with data lake, features like proper data partitioning, security of your data, labeling of your data, and making it look more like a proper lake than improvising Amazon S3 as a data lake. The next we have here is Athena, which is another beautiful serverless service that is used for analyzing and for querying data. Basically, I call Amazon Athena the SQL for no SQL and for SQL. What that means is you can actually use Athena to query JSON, Parquet, ORC files, compressed data files. So it's always advisable to compress your data as part of your transformation process. What that does for you is that it saves you a lot of data transfer. It saves you time to query that data, and it also saves you time in terms of analyzing and getting a lot of insights from that data. So Amazon Athena is a beautiful UI that connects to S3 and queries your data in that form. So data Athena queries, like I said before, such as CSV, JSON, Parquet, and ORC. So Athena, you can practically run SQL statements, okay, and see SQL statements on Athena to query and read this data and get your output back in S3. The next here is Amazon Kinesis. So Kinesis is actually a family of services, okay? You have the fire hose, you have analytics, you have the video streams. So Kinesis is basically for streaming data. So when I talk about streaming data, I'm talking about, as we are on this video call, we are talking about streaming data, okay? As I'm talking, this data is being streamed to people all over the world watching on YouTube and also on this channel. So you can actually pick information from this this stream and start analyzing it and getting insights into this. So Amazon Kinesis is very beautiful for that. It might not be video stream, it might be data streams, okay? When you're getting hundreds and thousands of users visiting your application, you're going to get a lot of traffic and a lot of data will be generated. You can pipe this data through Kinesis and perform a lot of analytics, analyzing and cleaning of data. We'll be looking at one of the case studies very soon on how we use Kinesis as a very beautiful tool for ETL and for data analytics process. The next we have here is Amazon Elasticsearch Service. So Amazon Elasticsearch Service is a service that helps you for analyzing data. So Elasticsearch is a unique service that is very good in terms of it's an out-of-the-box search engine, okay? When you write data to Elasticsearch, Elasticsearch has a beautiful algorithm written in Lucene that helps you to perform similarity search of data. So instead of the way you query for data in a normal database, Elasticsearch has a method of creating priority for your data and gives you results that are related to each other. Instead of giving you verbatim results or giving you results that are not related, Elasticsearch gives you related services, which is very, very good and important when you're trying to analyze data and you're trying to get things that are similar or things that are not similar. So Elasticsearch service is very beautiful and very good for that operation. The last we have here another list is what we call Amazon QuickSight. So Amazon QuickSight is the face of everything we are looking at. So when you've extracted your data, you've transformed your data, you need to bring out the insights that people can understand. When you are publishing reports, okay, for the C-level executives, for the accounting team, for every other part of the business, you need to put that data and represent it in a graphical form that they can look at, they can understand, and they can actually extract deep insights from. For example, you want to know, how many people globally are using a particular service in AWS, in what part of the world they are using that particular service. What is the frequency of females to males that use a particular service? What is the frequency of males to females that are in cloud computing field? These are the kind of insights that can be given by QuickSight based on the raw data that you have performed ETL process on during the whole process of all the services I've spoken about. So Amazon QuickSight, it's the face of your data. It's what gives you insights in a graphical form using things like pie charts, bar graph, histogram, and every other visualization tool you know about. So QuickSight is very, very good at that. So without further ado, let's be a little bit realistic with a practical case study. So let's not just talk about the services and talk about data engineering. Let's look at a real life scenario and how data engineering and machine learning was able to help. So the problem statement here is there's a marketing company that collects data of users from various channels, which mostly includes web campaigns and mobile ad bidding. This data includes cookie data, location data, user journey, and more. Due to the various databases used to build the campaign service, some data are actually structured as relational and some are unstructured, which could actually be data that could reside, say, in MongoDB, in Elasticsearch, or any other kind of NoSQL database. Now, the tech team have been tasked with creating a machine learning model based on this data that can help predict user journey based on historical data, which will help to improve the performance on future campaigns. So this is a very real life scenario of something I've worked on personally. So this was a real problem, and we needed to look at data engineering and look at the AWS tools that we could, fix together to actually solve this particular problem and, generate more value for our customers and then bring more to the business. What we did was to think about how we could actually work it out. So we created a scheme of how this was going to be resolved, and this was the flow of the solution. So the first thing was to extract data from various databases both those used by the applications and the databases that were output data is written to. So we chose Kinesis for that particular option, and then we wrote some bash scripts because the data were both streaming data and data at rest. So data in motion or data at rest. What we did was to ensure that the data being transmitted is actually moved in a form that we can use Kinesis to move that data from one location to the other. And then for the bash scripts, there were cron jobs, okay, background processes that were daily pulling data from those locations and dumping them in the data swamp, which is the next step, which is storing this data in a temporary location, which is the data swamp. So after extracting the data, the data becomes in a form that you need to dump in a particular location. And then we use S3 as our data swamp, which was the first stage of dumping the data. So the third step was to scan through the data in the data swamp to have a bird's eye view of the data. So there were different data that existed. We have data from the campaigns. When the campaign is done, the user has a journey. The user goes from websites A to B to C to D. The user exits the browser. We need to understand what actually exists in terms of the raw data that we have existing. Based on what we understand and based on what the business needs to get done and what the business needs to get delivered, the next thing we did was to actually look at how we could build a transformation layer that helps to compress, merge, and flatten the data, removing noise or unnecessary parts of the data. So that was what we could do because we now understand what the data has. We now understand what is in our data swamp. We now understand what exists there. So when we did that, we were able to build that clear transformation layer using tools like Amazon Glue to clean up the data and put it in a form that is going to be more valuable to us. The next stage was to build what we call a data lake. Now, the data lake is where the data we have transformed, the data we have cleaned up that now looks much better. This is where we eventually write that data into. So at this point in time, the data starts making sense because we have removed the noise, we have removed what we don't necessarily need anymore, we have removed the data that is not so relevant for improving the performance of the campaigns. And then the next stage was to use an analytics tool to scan through transformed data that needs to meet the needs of to see if it meets the requirements. So there are certain requirements we have. We're trying to improve campaign performance based on the data that we have. So in doing that, we had to look at what has been transformed. Does it conform to what we want? Does it meet what we want? There are some cases that we actually did not perform transformation well. We will have to go back to the transformation process, retransform the data, and bring it back to the lake and then reanalyze. So it's more of a continuous process. I call it continuous ETL, okay? Just like DevOps, where you have continuous integration and continuous delivery. So ETL is a continuous process of continually fine-tuning that data until you get the best kind of data and solve the business problem you're trying to resolve. When that is done and we are sure that the data is clear enough, then you have what you call pushing data over for analytics and for ML and model training. So this is where SageMaker comes in. So from this point in time, we'll plug our data into SageMaker using the SageMaker connector, connects to S3 directly, and you can build a model around that you can train because you now have data that you trust, data that has been cleaned up, data that is ready to go into the training of the model so that that model can be very efficient and meet with the business goals that you need to achieve. So this all came down to an architecture that looks exactly like this. So the architecture is stores. First of all, we have data in our EC2 instance, or this could be an RDS instance or any other kind of storage where we have the logs, database information and everything. So the first thing is to extract this data and take it through Kinesis Firehose. But what we have that we use for this extraction is what we call the KCL, which is the Kinesis Client Library. Now, client library can sit as a daemon process in your server. What it does is that it pulls data from a particular location and pushes it through Kinesis. Okay, it's more of an API call. It takes the data in batches and pushes it through Kinesis and calls the Kinesis API to push data over to the data lake. But before the data gets to the data lake, we need to perform transformation and we need to check what if we have 6 columns in this data, how many columns do we need? 5 or 4 or 3? Okay. At this point in time, we get rid of noise in the data. Any column or any data point we know is going to cause is going to give us wrong results. Okay, we get rid of it at this point in time, and that's where the Lambda function comes in. So the Lambda function is a serverless service that can help you deploy applications for various purposes and reasons. I won't go too much into Lambda functions today, but there's a lot you can do with Lambda function. But at this point in time, we use Lambda function to clean up the data, perform the first layer of transformation on the data. So as the data moves through the Kinesis firehose, we are transforming the data and writing it eventually into S3. As it moves through Kinesis firehose, a Lambda function is triggered. It looks through the data, checks if there's any noise in that data, remove the noise, and then writes out the output into S3 while the raw data still exists in the data swamp. So as our data swamp is growing, our data lake is growing, because we are continually dumping the raw data in the swamp and then also writing it through Kinesis firehose via the Lambda function that cleans it up, and then eventually to the data lake storage. And then when it gets to data lake storage, the next thing that happens is that Glue crawls through the data. So apart from Glue being an ETL service, Glue can also crawl through data in S3. And what that does for you is that it helps you to standardize your data for Athena querying. So with Glue crawling through the data, it's able to actually classify that data for you. If it is a Parquet data, if it is JSON data, if it is CSV data, and that classification can be very helpful in understanding the schemas and a lot of other information about your data that you just performed your transformation on. And something that's very interesting about this is that when you are able to cross through that data with Glue, it makes it very easy for Athena to work with that data and query that data and gives you proper visualization of what exists in that data. Now, part of the things we also did for the Lambda transformation was also data compression. So I talked about data compression before, I'm talking about it again. So in data engineering, compression of data is quite critical because they're moving terabytes of data. You don't want to move that all the time because it can be very time consuming. It can be very cost consuming because you spend a lot of money transferring data, whether you're transferring cross region or within your AWS account. And it's also very difficult for analytics services, okay? Even when you're training your models, if your data is not properly compressed and easy to work with, it becomes difficult for those models to get properly trained. So compression of the data is quite important and very good. So what we use for this compression is actually Parquet, okay? P-A-R-Q-E-E-T, Parquet. It's a very good format for compressing JSON or CSV data into, and it's quite readable by a lot of libraries, a lot of plugins. Even within your SageMaker notebook, you can actually query and read and Parquet data. So though it's compressed, you can't view it with a text file, but it's actually viewable by a lot of other services. So that was what the Lambda transformation also did. Apart from just cleaning up the data, it was able to compress the data. And then eventually when it gets to Athena, Athena beautifully can read Parquet data. So you can actually query your compressed data, which saves a lot of data transfer from S3 into the Athena service. And then your queries become almost 5 times faster than the original JSON or CSV format that you had that data in. The machine learning services or frameworks in AWS, I already talked about Amazon SageMaker, how we use Amazon SageMaker to train the data. So to train the model. So after data is available and ready, the last stage is actually either analytics or machine learning using Amazon SageMaker. And we also use scikit-learn too as the algorithm to particularly train the model and deploy the model when we are done. And whenever we need to train the model, we go through the ETL process. The serverless ETL pipeline cleans up the data, makes it available. SageMaker reads from the S3 bucket, that's how the data lake, and we are able to deliver more value at the end of the day. Thank you very much.
Thank you so much, Mr. Awere. That was very comprehensive, very deep, and very enlightening. Thank you for sharing with us. Thank you so much. I want to welcome Griffin to take us through a short Q&A session. Then we can continue from there. Thank you so much.
We only have one question so far, and still want to encourage everyone to keep pushing your questions for the speakers over there, so that we are able to get them at the tail end of their presentation. So keep pushing your questions on to the link that is shared with you.
I think that computers being able to understand language has been one of the most amazing advances in AI. NLP has changed a lot over the last several decades. The field has started off using primarily rule-based systems, to then using probabilistic systems, to now where NLP relies much more on machine learning and deep learning. In this specialization, you learn everything from being able to translate English to French, to understanding if a customer review is a positive review or a negative review, to building a customer service chatbot, to letting a user enter some text and using that to do web search or to do online product search.
More recently, with the rise of powerful computers, we can now train end-to-end systems that would have been impossible to train a few years ago. We can now capture more complicated patterns, and we can use these models in question answering, in chatbots, and in other applications.
A few years ago, these models would take weeks or even months to train. But with attention, you can train these models in just a few hours.
I'm really excited for everyone to get started, to take these courses, learn these technologies, and to go build some great NLP systems.
Mo Ribai, Deep Learning Specialist at Ribai Analytics Group. I studied mathematics and I have been engaging to the AI and data science field since 8 years ago. Actually, I started in 2012. I also currently work as project creator on Coursera and mentor at Deep Learning AI and alpha tester at Workera. I would like to tell you about an article that I've published on LinkedIn. You can go through this article. You can search my name, Mo Ribai. In this article, you will know the best learning path in AI and data science and machine learning at Coursera, using different tools and learning various topics. You can take courses in Python, in R, in MATLAB, and it's really a useful resource for you to start learning AI. So first of all, I want to tell you about a course from Amazon Web Service. It's the Getting Started with Amazon Web Service Machine Learning course. This course will teach you how to get started with machine learning, like computer vision tasks, NLP tasks. You will do NLP projects, computer vision projects. Each topic consists of several modules, deep diving into variety of machine learning concepts, as well as insights from AI experts to put those concepts into practice. Also, there is a great program by Deep Learning AI at Coursera. You can start with an introductory course. It's AI for everyone. It includes a brief and amazing introduction to AI by Andrew Ng. It's like about 6 hours course. You will take it during your weekend to start with AI. Then you can take any machine learning course on Coursera. You will find many machine learning courses, a lot of courses available at Coursera. You can take the machine learning course by Andrew Ng, and it was published, I think, at 2012, but it's still being the top machine learning course, online course worldwide. If you do this course, the machine learning course by Andrew Ng, I prefer for you not to go through the assignments because they are designed with Octave. And you know, nowadays, Octave, it's a bit hard to learn. I work on Octave and on MATLAB, but it's not necessary to work with Octave. You can just watch the video lectures by Andrew Ng to get a great idea about all machine learning algorithms and how algorithms work. Then when you finish this course, machine learning course by Stanford, taught by Andrew Ng at Coursera, even you can take any other machine learning course like machine learning specialization by Michigan University. You will find a lot of courses at Coursera. After you finish this machine learning course, you can start with the deep learning specialization by Deep Learning AI at Coursera. It consists of 5 courses. You will learn the foundations of deep learning. You will build neural networks and learn how to lead successful machine learning projects. You will learn about convolutional networks, recurrent networks, LSTM, and regularization techniques, normalization techniques, and more. This specialization is highly recommended for you to start learning deep learning because AI is still now at the beginning stage. And you know, as we have more data, we should learn deep learning. It's true that traditional machine learning algorithms are very useful to solve real-world business problems, but with deep learning, you can deal with bigger data sets. With a huge amount of data, you will solve much more complex real-world problems. So I recommend to take AI for Everyone course, then any machine learning course, followed by the deep learning specialization that consists of 5 courses at Coursera. By accomplishing this deep learning specialization, you need to learn how to build scalable AI powered algorithms. You can then start with TensorFlow and practice specialization because if you learn TensorFlow, you can fastly learn how to build practical deep learning projects with fewer lines of code. Let's say if you want to build a chatbot, it may take you about 100 line of code. With TensorFlow, you can build a chatbot with about 30 or 40 lines of code. So this TensorFlow practice specialization taught by Lawrence Moroney, who is a Google advocate, is very helpful, very useful. It's really amazing. You can start with this specialization after you finish the deep learning specialization. You will learn how to implement deep learning projects, practical projects with TensorFlow and computer vision, also in NLP and time series forecasting and prediction. Okay, after this specialization, you can move on into the TensorFlow data and deployment specialization, also taught by Lawrence Moroney at Coursera. I want to tell you something about deployment. Nowadays, you know that the AI community worldwide, it's getting bigger by time. Day after day, more people are engaged with AI, are learning machine learning and deep learning techniques, but there are still many problems with how to deploy your model, how to put your model into production, how to make your model useful to solve real-world problems. You know, now we are facing the COVID-19 pandemic, and there are many data sets available online. You can train a machine learning model to predict, let's say, the growth of this virus in a certain country, but you don't know how to deploy this model and put it and create a useful AI system. With the TensorFlow data and deployment specialization at Coursera, you will learn how to build deep learning projects and how to deploy them. You will learn how to deploy deep learning projects on the browser, let's say to deploy your model on a website. You will learn also how to deploy your model on edge devices like smartphones, and you will learn TensorFlow JS, TensorFlow Lite, also TensorFlow serving. You will learn amazing things about TensorFlow and how to deploy those projects. There is a new specialization also by deep learning AI at Coursera. It's the AI for medicine specialization for those who like to build deep learning projects in the healthcare industry. And as you know now, it's like it's trending nowadays, the COVID-19 situation. You can build deep learning models for medical diagnosis and like that. But it's not necessary to take this specialization. If you want, you can take it later. You can take, after you finish the TensorFlow data and deployment, immediately you can take the NLP specialization, which we watched the video by Andrew and G about it. This NLP specialization is also very useful. I think it will be the top NLP specialization because it contains really coherent material and content with amazing projects. This NLP with classification, with NLP specialization is now available at Coursera. It consists of 4 courses. 2 of those courses are released, and you can start with them. The first course is NLP with classification and vector spaces. The second course is NLP with probabilistic models. Third course is NLP with sequence models. And the last course is NLP with attention models. You can go through the first 2 video lectures of the first course to know what those courses talk about, and you will get a better idea about those courses. But I highly recommend to take them because NLP nowadays is also being challenging, and you can solve very complex problems with NLP. Also regarding the financial aid at Coursera, I can contact Kennedy. We can help you take all these courses for free. You can apply for financial aid and wait only 14 days till the submission approved by Coursera. You are able to audit any course for free, not to start a 7 days free trial. If you audit any course, you will have access to the video lectures, but you don't have access to the assignments. So you can audit the course for free, start watching video lectures, and apply, send or submit a financial aid application. We can help you in the how you can or what you should type to send it, the messages and like that. And also I would highly recommend you to start at Coursera taking online courses, because Coursera platform, for me, it's now the best platform teaching AI, because they are following a coherent pattern of courses. You can start really from zero to hero in machine learning and deep learning. There are many other useful resources, like you can watch on YouTube the deep learning course at Stanford University. This deep learning course taught by Kian Katamfurish and Andrew Ng. It's like the deep learning specialization at Coursera, but with more features, with more explanations, with more topics, like this available on YouTube course, the deep learning course by Stanford. You will learn how to implement GANs, generative adversarial networks also. You will find more topics than the topics covered at Coursera. Also, you can take a series of lectures at YouTube by Lawrence Moroney, who is, as I told you, the lecturer in the TensorFlow and Practice specialization and TensorFlow data and deployment. In this series on YouTube, you will also learn how to build computer vision tasks, NLP tasks. You will learn how to implement deep learning projects with TensorFlow easily. So this is about courses and online program. Also, the new NLP specialization. I was an alpha tester in this specialization and now mentor at Coursera. We have created a Slack workplace for learners to discuss and ask if they have any issue. So we can always help you. Regarding the data sets, you can search. Nowadays, you will find many resources to get a data set and work on. Let's say you finish a machine learning course and you want to build your own projects. I can share with you at the end of this meetup the resources. You will find data sets on Kaggle, on GitHub, Google dataset. Also, you can find data sets on Stanford Online, this website for Stanford University. Also on pathmind.com. You will find also data sets on Amazon website, on Microsoft, Lionbridge. Also, you can find data sets on Archive. I would like also to tell you about Archive. It's a great place for you to read machine learning and deep learning papers. Some of my friends keep asking me about Archive and what type of papers I should read to get more experienced in machine learning. Please don't read the complex papers, don't read hard papers. You may be interested, let's say, in GANs, but you are not yet, or you haven't took any GANs course in deep learning. Don't read papers about this tough topic. Just start with papers about traditional machine learning algorithms. Then you will move on into papers on deep learning algorithms. And by time you will be able to read more complex papers. I recommend you to always read papers, read blogs, try to daily read blogs about AI, keep updated about all AI news. Every day we have new technologies, new AI systems. Also, I recommend you, beside taking courses and searching for your own data sets on resources I've mentioned, also beside reading papers, beside reading blogs, to join competitions. You can find many resources to join competitions in AI, like Kaggle and Omdena, for example. Also, I would like to tell you about Workera AI. And now I'm an alpha tester at Workera, and we are trying to build a great questions in all AI topics, like in machine learning, deep learning, mathematics, algorithmic coding, data science, and software engineering. Workera AI is a company founded by Deep Learning AI, and the founder of Workera AI is Kian Katamforosh, who is also a friend of Andrew NG. On Workera AI, you can do a standardized test to test your AI skills, and you have like I think 3 attempts every month. So don't worry about repeating the test. The questions at Workera are really useful and let you find new job opportunities, but they are not easy. So don't go to Workera AI and take the test before taking a machine learning course, minimum 1 machine learning course, and let's say the deep learning specialization at Coursera. Even if you don't want to dive into deep learning, you are a software engineer, you can take the software engineer test, let's say the algorithmic coding, the mathematics test, the data science test. Just one note, please go through my article at LinkedIn. You will find a learning path for that will match your interest. Let's say you don't want to dive into deep learning, you want just to learn data science, you will find in my article specializations at Coursera to just learn data analytics or data science, or let's say, for example, machine learning. So don't miss Workera AI test. After taking few courses at Coursera, you can do the Workera test. As I mentioned, you have 3 attempts every month, and you can view the feedback on Workera, your strengths and weaknesses. You will get a certificate, you will view your test performance, you will know exactly what are your skills in the AI fields. And there is a career track also on Workera. They will recommend you to open job opportunities. And there is great news for you that we are talking with the Workera team. We were asking Kian about now in this pandemic, in this situation, many companies want to hire people or candidates as remote work opportunities. So Workera in the near future will add a new feature. If you do the Workera tests, you may be recommended to work as remote work in the AI startups and AI companies. That's about data assessments on Workera. My last point is about reading books and AI. I will tell you about 4 books which are helpful books. Also, after the meetup, I can share with you the resources. The first book I highly recommend it for beginners in data science and machine learning. If you are a beginner at Coursera, you don't know what are your interests, what is your future career path, you can read this book, Build a Career in Data Science, by Emily Robinson and Jacqueline Knowles. This Build a Career in Data Science book is your guide to landing your first data science job and developing into a senior employee. By following clear and simple instructions, you will learn to craft an amazing resume and be prepared for interviews. You will know the difference between the, let's say, data analyst job, machine learning researcher, machine learning engineer, digital analyst, data science, data scientist, deep learning specialist. You will know the difference between those types of jobs in AI. The second book is Machine Learning Yearning by Andrew NG. This free book, you can find it on Deep Learning AI website. It teaches you how to structure all types of machine learning projects, not teaching you the machine learning algorithms. You can take, as I mentioned, the machine learning course by Stanford at Coursera to learn machine learning techniques. Then, if you read this book, you will be able to structure and build strong machine learning projects. Also, the third book is an advanced book in deep learning. I recommend it for people who are currently learning deep learning and taking deep learning courses. It's the Deep Learning book by Ian Goodfellow, who is the former student of Andrew Ng. And this book also will give you a better knowledge about deep learning, and you will improve your practical skills in deep learning. The fourth book is Hands-on Machine Learning with Scikit-learn, Keras, and TensorFlow. You will learn the concepts and tools and techniques to build AI systems. So those four books: Build a Career in Data Science, Machine Learning Yearning by Andrew Ng, Deep Learning book by Ian Goodfellow, and Hands-on Machine Learning with Scikit-learn and Keras and TensorFlow. By reading those books, with reading blogs, reading papers on arXiv, taking online courses, you will build great skills in AI, and you will be able to really solve complex problems and contribute to the AI global community. So that's for me. Also, I would like to tell you there's two important things you should know. First of all, it's communicating with people, meeting new people, joining AI webinars, communicating with AI influencers, with AI fellows. Always communicate with people, share your certificates on social media, meet new AI fellows, send them messages. You will learn from others, others will learn from you also. By communicating with people in this AI domain, you will also improve your skills, your communication skills, your technical skills. You will learn a lot of things, be active on social media. The second thing is time management. Time management is essential also to achieve your goals, your dreams, your success. If you manage your time, I will give you an example now. For me, every day I read a paper, I read a blog, I take some online lectures, I do some work with AI. I have many things to do just because I manage my time. So don't waste time. Time is the key of success. Manage your time, keep motivated. Try always also to help others learn AI. When you help people, you will feel that people also will know you, will support you. You will feel more happy with your domain, and you will reach all your goals. And my last thing to tell you is, don't think that any AI pioneer now is better than you because this person just studied and work hard to reach this point. You can also reach this point, and you can write papers later on about AI, and you can change the future with AI. So before I finish, also my last message is to work with ethical AI. Try to build ethical AI systems. Don't just work with data sets or models that discriminate between things, or like biased data sets. Pay attention to the type of data set you are working with. Try always to build ethical AI system. Be ethical and That's all. And thank you for your time. Now I welcome any question.
Thank you so much, Mr. Mo, for that enlightening session. Thank you for that discussion on narrowing down on the courses and programs and paths to take and to breaking into AI and data science. Thank you so much for that and for spending time with us today. I'll now welcome Griffin to take us through any Q&A session in case of any question. Welcome, Griffin.
Thank you so much, Lydia and Mo. I have one question for Mo, and
Yes.
I will put it up on the screen right away. So Mo, there's somebody asking, are there any mentorship programs to becoming a deep learning expert?
Okay. Regarding mentorship programs, now we are building our own platform. It's AI readiness platform. It may take some time, but I think after, let's say this year, we will launch our mentorship program for individuals and startup to adapt to the AI transformation, and I'll announce it on social media. Yes.
Okay, that's great. So I think for whoever asked this question, ensure you follow Mo and be on the lookout for any of his posts.
Sorry, but just one more thing. I can also help all AI fellows to start with AI. You can contact me through LinkedIn. Just type my name, Mo Ribai. You'll find me and just send me a message, and I'll be there for you also. I'll be your mentor. I'll help anyone who asks me to help. Thank you.
Before I can ask the final question, there were polls that were thrown to you before, and we had asked you initially to tell us one thing you hope to get out of the webinar today. And the results we have so far, 77% say they're totally new to AWS and want to understand the basics. 23% of you say you are proficient and only want to get insights and opportunities. So do take part in the last poll. Tell us if today's webinar met your objectives. Do let us know if today's webinar met your objective. Now, to one last question. I think Mo went through this. What papers should beginners in deep learning literature begin with to read?
Okay. First of all, I'm very happy to be with you today, and I always encourage others to manage this online meetup, because when we meet, we learn from each others. If for beginners in deep learning, don't just immediately dive into deep learning. First of all, you should know the traditional machine learning algorithms, how they work. It's not necessary to learn the mathematics behind algorithms or how they develop those algorithms. You should just know how machine learning algorithms work. What is decision tree, for example? What is random forest? What is support vector machines? Then you can start with deep learning also by understanding the theory behind all algorithms. Like if you want to build a machine translation, for example, it's a very simple idea. Machine translation is a translator to translate from one language to another. Take things easy. Also, if you want to build a chatbot, you will build like a bot, let's say a virtual bot that will communicate with you. Try to always get the theory behind algorithms. and how they work, and try to interact with AI, with deep learning algorithms, you will find it easy. But don't just learn courses and stuck into like some pieces of code, because coding, it's just like a tool to implement your projects. Coding is not the big deal. The most important thing is to understand the algorithms and how they work and why I'm learning those algorithms. The coding part is very easy. You can find nowadays resources for all machine learning and deep learning projects. So for beginners, just start on Coursera, as I mentioned. Read my article at LinkedIn about the learning path at Coursera. You will find the machine learning specializations and courses for beginners, not necessarily the machine learning course by Andrew. You can take easy courses. Then you can start with deep learning specialization by Andrew. Also, you can skip some mathematics illustrations. There's no need to understand everything, every math behind deep learning algorithms. Just interact with what you are learning and read books, easy books, read blogs about AI, as I mentioned. It's very easy, and any beginner who want to start at Coursera, just like follow AI news, daily news, you'll find yourself right there in this global AI community. And always I'm open to help others. That's
Great. So I think because of time, we'll forward rest of the questions to the other speakers and have them forwarded through your email. But I want to believe most of them were answered. You will be able to get the slides. They will be sent to your emails. That is if you signed up. And to the other questions, we'll have them answered and forwarded to your emails. So in the interest of time, allow me to, at this point, invite Sylvia to wrap up the webinar for us. Sylvia.
Just one point. I sent for to everyone my email and my LinkedIn handle.
And now we've come to the end of this lovely, lovely session. I believe that we have all gained so much from this session, and we'd love to express our gratitude to all our speakers, Mr. Jianjun Su, Mr. Mo Rebaye, and Mr. Ewere Diagboya. We are honored that you graced us with your presence and for taking us through the topics very, very well. We do appreciate. Also, for all those who took their time to register and attend, we appreciate all of you so, so much. And I'd like to take this opportunity to remind you all of the post-event survey. We encourage you to fill the survey and express how the session was for you. We'd love to hear your comments and feedback. You'll also receive a promo code for deeplearning.ai courses, where you'll get 50% off for the courses using that promo code. So kindly fill the survey and feel free to use the promo code. Also, a big thank you to the organizers who made this event possible. Special thanks to AWS Educate and deeplearning.ai for facilitating the webinar. This could not have been possible without you. Once again, thank you very much to all those who attended. Hope you all enjoy the session, and until next time, stay safe and